Hello, Mrs. Henderson back for the very last video in week 1 looking at the properties of water, and this is my favorite property. So when we were looking at water before, we were talking about its ability to make hydrogen bonds. So between the hydrogen of one molecule and the electronegative element of another one. So in this case, hydrogen in the water molecule with the electronegative oxygen of a molecule that's right next to it. So it can make this hydrogen bond. And we call this cohesion. So the molecules of water are cohesive with each other. And cohesion just means joining together, being bonded together. So you even use this in like normal English where we talk about a cohesive group. And a cohesive group is a group that's well bonded, that works well together. So I hope AP Biology will become a really cohesive group this year as we all learn about each other and how to work really well together with each other. So because it's cohesive, water does really cool things. So for instance, water forms water droplets. And you'll notice when you've looked at like maybe dew out on a plant or when you have seen droplets like fall, that they seem to kind of drop together in these structures that are very much like water droplets, right? Like circles or spheres of water. And you can see how that would happen in the molecules of water, the models, but I also want to show you it in real life. So this cohesion piece is really cool. So this is just wax paper, and I'm just going to take a couple of water molecules from this glass. I've just put some food coloring in it, and I'm going to put those water molecules just onto this paper so you can kind of see it. I'm hoping you can see this really well. I'll make a couple really big ones. And you can see that on this wax paper, and wax paper is non-polar, so it's really hydrophobic, that it makes these kind of cool, spheres or droplets of water. Those are just connected. So the cool thing is that if I now kind of roll them, and I can do that, I can roll them around so they'll move on the surface of this water. Whoop, that when I roll them together, they kind of join each other. If you've ever played like Agar.io, I think of it kind of like Agar.io where they're going to join together. So let me do that again so you can see it. And actually, let me see if I can get a little bit closer for you. So here's my water droplets. I'll just put a few kind of little piles of them. And when I bring them together, so when I roll them, and you could try this at home if you want to, when they get close to each other, just like the old water molecules, they'll kind of join each other. Here it goes. And then it'll join into one big one as it kind of one eats the other. So here it comes again. Here comes a big one to get the little one. When they get close enough to each other, they're going to go ahead and join together. And notice like the way that they move, right? That it's all in this kind of, it doesn't spread out like it would do on a piece of paper that isn't polar, but on this waxy surface of the wax paper, it's going to maintain that kind of cohesion that keeps it all together, all hydrogen bonded in there and not flat, right? Not spread out, but in this kind of nice sphere or dome shape. I'm going to go ahead and put that back. The other cool thing I wanted to show you is how this creates surface tension. And surface tension is those hydrogen bonds on the surface that create almost like a solid layer, that they're joined together, and so they're connected like that web of water molecules where like water bugs can walk on water. It's the coolest thing. And I wanted to show you this with a kind of fun experiment. I'm going to just pour some water into this, over my bin, into this this container of a mason jar, I guess is what you call it. Okay, and this is a mason jar, and it just has some window screening, so it just creates little holes, but you can see that water poured right through. So the cool thing about surface tension is it allows me to do some kind of fun tricks. So I'm going to put an index card over the jar, and I'm going to upright it. And the coolest thing will happen is the water will actually stay in the jar because it's cohesive at the surface, at that netting, that window netting that I showed you in just a second ago. And what's even cooler is that if I take this away, the water is still in the jar, right? Like it's not falling down because it's bonded to all those little pieces of window netting into itself. It's cohesive. It's almost like webbed together on the surface, holding all the other water molecules in the jar. And if you were thinking there's some trick here, if I turn it, if I break that surface tension, if I break just a few bonds, then the water spills right out. So the water comes right out of the jar. So that's surface tension. And that's what allows molecules, like paper clips, to float on the surface of a water. If you've ever seen that, it's pretty cool. It's what allows those the water bugs to be able to walk on the water too, or stand on the water, if you've ever seen that. So that is surface tension, and that comes because water is cohesive. It has the property of cohesion. Okay, that's it for these videos. I'm hoping you enjoyed week 1. I look forward to showing you all about macromolecules next week. Enjoy your projects.